Subscribe to AmpCode and ring the notification bell to get the latest content.
So now let's talk about some of the data frame operations which are present in PySpark. So what we have seen is how we can write a simple SQL query on top of the data frame. But we also have some native data frame operations that we can use to really speed up the operations, and these are really simple to implement. So if we talk about PySpark, we have different sorts of operations like filtering out to filter your data, as well as we have to, if you have to select some specific columns from the data frame, then we have the select operation, and also we have some aggregating operations as well, which can group the data together to give you the aggregated output. And also we have like several operations like explode and all, so that are pretty advanced functions, so that also we are going to see subsequently. But why waste any time? Let's jump on to our Jupyter notebook and let's see all the operations in action, so you will be able to understand it very quickly. And also Spark is able to handle complex data structures. So if you are dealing with array where we have like nested values in that array, that columns are also supported by Spark, and you can also able to run Spark SQL queries on top of that as well. Just needs the syntactical differences in the normal SQL query and the Spark SQL query to fetch the array columns. So basically Spark is pretty versatile due to this reason. And also data frames are immutable. We have already seen this in our RDD topic, where we have seen that we cannot change the RDD since it is immutable, but we can generate new RDD with the help of the previous RDD using some transformation or action. So similarly, data frames can be created using the previously created data frames, and we can apply all sort of transformation, but we cannot change the existing RDD. So let's jump onto the code and let's discuss all these operations in detail. Okay, so as you can see, we have simple code here. This is pretty different. So here we have the data as well as the columns here. So basically the first thing you have to do is you have to just import the PySpark session from the pyspark.sql and some simple functions that we are going to use in this code. So basically, as you already know, the first step of every Spark application is creating the Spark session, and the Spark session has some application name, and it is active once you kick off your Spark session. So it will run all your workloads on the cluster with the help of the Spark session. So basically all you have to do is first just import the modules, and after that let's create a Spark session. So it will take maybe 10 to 15 seconds to create a Spark session for you. And here, as you can see, we are going to create a data frame on top of the list of the tuples. So basically we have different tuples which has the data, like we have the name, we have the age of that person, then we have the gender and the salary that particular user has. So basically we has this data, and so let's, for beginner purpose, I have just kept it as 4 rows, and we have the column names as well. So we have the schema as well as the data to create our data frame. So basically we can use the create data frame function to able to create the data frame on top of this data. So basically I'll give the data as data and the schema as columns. So once it is created, so let me just execute this parallelly and it will get created. So you're pretty much aware of the next operation, which is show. So show is basically to analyze your data on the go. So in Jupyter Hub, show is pretty useful operation because you can able to peek into your data and see if it is coming in correct format. So it is great for analytics purpose as well as the validation purposes. So as you can see, our data frame has been created. So all you have to do is you have to just show the data frame. So this is just showing the original data frame. So as you can see, it is taking so much time. It's just 4 rows, right? Let's talk about this as well in the optimization topic. So just notice it is taking like around more than 5 seconds to just show the data frame to you. And as you can see, we got subsequent operation on this data frame. So I hope you already got what I'm talking about. We can use the cache function here to really cache the data frame in memory. So as you can see, we got our data. So basically we are just having the 4 columns and 4 rows in our data frame. and it is pretty simple structure. The first operation that we are going to discuss is the select operation. So select is basically used for selecting some specific columns from your data frame. So as you can see, if you really need the name and age column, that's it. If you just need those columns in your subsequent task, then you can use the select method, or you can say select function, and you can just give the list of columns that you need inside that function. So as you can see, I have just used the select function on our df and just took name and age column and just showed it, because as you already know, Spark has a lazy evaluation. So basically Spark will only run the job once you call out some action. So here our action will be show. So I'll just run this. So as you can see, so it is really again accessing the disk here to able to process that data frame, and if you use the cache, it should be present in memory. So that's why we will able to leverage that and see, because these are all the iterative operations on the same data frame. So as you can see, we got the two columns here. So this was our first operation. The next one is the filter operation, which is also often used to filter out your data and to get you the required output. So let's say if you have a data frame having like data of different regions and you only need the records of a specific region, then you can simply add a filter on top of the region and get your required output in some specific data frame. And also like here, we are just filtering out the data on the basis of the age. So here we'll get all the users who has the age greater than 30. So once we execute this, it is again taking the time, right? So just notice that it is taking like 5 to 10 seconds to run every operation. It is just taking so much time to run all the operations, and we are just using the same data frame again and again in our code. So to simplify this and make this process very efficient, there comes the cache and persist operations in picture. So as you can see, we got the all the columns, but we only got the users having the age greater than 30 here. And also these are pretty simple operations, but there are some intermediate operations which are like aggregating operations, which are like groupBy, as well as the count operation is also there. We got the sum and average. So basically these all of mathematical or grouping operations are useful to get the whole picture of your data. So to get you a high level idea of how many customers they have, what is the average salary of those customers, and so on. So you can do all this stuff and get the meaningful insights using the grouping and aggregating operations. So basically what we are going to do here, we are just grouping the data by the gender. So basically our data will be grouped as male and female, and we are using the aggregate operation. So basically the first step will be, we'll count all the males and females, and that will be stored in the count. Then we have the sum of the salary of each, and then we will give the total salary as per the gender, and then we will get the average salary as per the gender. So basically we will be having all these columns, and the rows will be grouped together as per the gender, which is male and female. So hopefully we will get two rows in our data frame having all these generated columns. So as you can see, these are all generated columns, because the count we don't have it in our data frame. Then we have like the total salary, the average age, etc. So let's try this out and see the output. Okay, so as you can see, we got the male and female two rows having the count, which, so in this case we have the 3 males and 1 female in our data frame. We got the total salary as well as the average age. So this is how you can use the grouping and aggregating functions in your data frame. So I'll highly recommend you to work with your data set and let experiment different grouping and aggregating operations, so that you will able to get some meaningful insights which you can showcase in front of your clients. So basically the next will be like joining the data frames. This is also very vital operations in PySpark. So when you are working in real development environment, there could be so many sources your data could be coming in. So your data could be coming from Hive, your data could be coming from Oracle, your data should be coming from S3 bucket, CSV file. There are so many numerous sources your organization can store data in, right? Because there are so many storage solutions present, and you can integrate all of them with PySpark. So PySpark has a rich set of libraries that I've already told you, which can pull the data from any sources possible. So for that, you have to union or join the data together to get the unified output of the data, and then you can do analytics on top of it. So many organizations has this set of different sources, and join operation will really help you. But you have to make sure that you are aware of what are the different types of join. Like if you know about SQL, you know what is left join, what is right join, what is inner join, and full outer join. So basically, if you are dealing with billions of rows, the selecting the join operation, selecting the left data frame and right data frame, or you can say left table or right table, and using the specific and required join operation is very vital, because your query may suffer if you're not using the correct join operation or the correct order of the table. It also depends on how many rows present in each table, which is the smaller table, which is the larger table. So this is whole lot of discussion. So we are not going to go into much detail about joins. I'll just demonstrate you how we can use the join operation on the two data frames here. So basically what we are doing is we are just using the self join. So self join means so you are joining the same table. So basically what I have done here is I have just given the alias. So alias is also useful when we are dealing with joins. So we can give the alias for each data frame. So in this case I have just created df1 and df2 using the df, and I have given the different alias on those data frames. And here I have joined that on the basis of the name column here, and I have used the inner join. So inner join will give us all the records which are present in both the data frames. And also here I have selected only the column from the df1, and I have selected name, age, and salary. So this is how you can do join operations pretty simply. So it will be join the the left data frame, then we have the right data frame, and we have the condition on top of which is like on clause in the SQL query. So here we are using like the column function to able to fetch the column and give it as a condition in our join. And basically the last argument will be the type of the join we have. And if you have like multiple columns and a join criteria, you can simply do that using the ampersand sign, and also separating each condition in the brackets, round brackets. So this is how you can do join operations. So if we just show this, it will join both the data frames here. So as you are seeing, this is taking so much time for just smaller data set. So cache will solve this problem, and we will run whole script in within a minute. So as you can see, we got the output. So we got the name, age, and salary from the df1. So this was pretty simple, but you can experiment it on your own if you know the syntax. So this is how the join operation works. The next operation is sorting the data, because sorting is also pretty vital operations when you are dealing with big data. So as you can see, it is a pretty simple operation. So we have the sort operation here, which is sort function, which takes the argument as the column name as well as which type of order by you have to apply. So here, as you can see, I have just sorting out or order by on the basis of the age of the employees, or we can say customers. And also we have the ascending operation as false. So basically it will apply the descending order by on our data frame. So if we run this, we will get the highest age of the customer at first and the lowest at the last. So this is how the sort operation works. These are like pretty simple operations. So that's why Spark is such a great tool, and data frame is very simple to learn because the operations are pretty simple, as well as the Python is pretty readable, and also you will get the benefit of Catalyst Optimizer. So that is our next topic, which speeds up the query, and it is not slower compared to the RDD. I know the RDD is the core API, but due to Catalyst Optimizer, we will get the same performance if we use data frames. So that's why the whole world is using data frames only instead of RDD. So as you can see, we got the sorted output here, which is the Charlie has the highest age and John with the lowest age at the last. So this is how the sort operation works. And also our last operations is like adding or removing the columns. because sometimes you have to generate a new column based on some condition, as well as if you have to drop some columns which you don't need in the final data frame, that also you can do. The first one is the with column operation. So with column operation will allow you to write your logic and add another column based on that logic. So in this case, I have just created the bonus column. So here our employees will have some bonus. So we have generated a bonus column. So the first argument of with column is the column name which you need to generate, as well as the value or logic you want to apply. So basically I have just given the 1000 value for all the rows here, and definitely, and here we can use the drop function to drop specific columns from our final data frame. So here I have dropped the salary column and just getting the name, age, gender, and the newly generated column which is bonus. So once we run this, we will get these 4 columns and all will receive the bonus of 1000. So this is running, so let it run for maybe 5 to 10 seconds. Okay, so as you can see, we got the name, age, gender, and the newly generated bonus column having the 1000 value for all the employees. So this is how you can run different operations on top of the PySpark data frame. So right now we have learned all about the PySpark data frame, how to write a SQL query on top of the data frame using Spark SQL, as well as their main operations which you can use to write your PySpark code. But definitely optimization will come into picture when you're dealing with billions of rows and billions of transactions every day. And in production environment, optimizations is the only thing which is important and critical for those applications.
So that's it for today. I'll see you in the next lecture.